Okay, hi everybody. So now I want to take a quick look at what it means to have negative exponents, okay, and what that implies in terms of the work you got to do. So here we go, we're going to have x to the a, let's say, but this case we're going to know that a, and I'm going to give myself a little space here because I'll show you what this is equal to here. Well, let's make it negative a. And so then over here we'll say that a has got to be greater than 0, okay? So a is going to be some value greater than 0, and I'm going to put a negative in front of it. And then later on we'll see what that means. Now to get there, I'm going to follow the same pattern I did in a previous video here. I'm going to start with 2 cubed, and I know that that's 8. And then below that I'm going to write 2 squared, which I know is 4. 2 to the 1 I know is 2. Okay? And bear in mind what the pattern is. In this case right here, to go from 2 cubed to 2 squared, I'm really just subtracting 1 from the exponent. I'm subtracting 1 from the exponent. And then here, on this side, I'm dividing by 2. To go from one step, I'm dividing by 2. So the next thing that I'm going to do here, I'm going to subtract 1. I'm going to end up dividing by 2. And we saw this before, that the next step is going to give you 2 to the 0 is equal to 1. But keep going. There's no reason we have to stop right here. So let's subtract 1 from the exponent, which is going to give me 2 to the negative 1. And when I divide by 2, well, it's 1 divided by 2, right? So that's going to end up giving me 1/2. Okay? And I'll be even more clear. This is 1 over 2 to the power of 1. The 2 is raised to a power of 1 here. I just want to make the connection here. And now we can keep going. Okay? If I subtract 1 from the exponent, I'm going to divide again by 2. Now, some people don't particularly like where this goes, but I'll show you. So 2 to the negative 2. And now what I'm going to do is I'm going to take 1/2 here and I'm going to divide it by 2. Now I know for some people we don't like working with fractions, so I'm just going to go over here and do it. So I've got 1/2 and I want to divide this by 2. Now bear in mind that when you're dividing fractions, one of the things you can do here is change it into multiplication by multiplying by the reciprocal. But it's always of the divisor that you're reciprocating. So I'm going to reciprocate this 2 here. So 1/2 multiplied by 1/2, well that's 1 over 4. Or, just to make this so it's consistent here, I'm going to write this as 1 over 2 squared. And I come over here and write this as 1 over 2 squared. And I can keep going. I'm only going to go one more step here because I think beyond a certain point here it gets pretty clear what's going on here. I'm going to subtract 1 from the exponent, so make this 2 to the negative 3. And then I'm going to end up dividing by 2. So let's go over here and do it again here. So I had 1/4, okay? And I'm going to divide this by 2, meaning I'm going to take 1/4 and I'm going to multiply by 1 over 2. Okay, multiply by the reciprocal. This is going to give me 1 over 8. And I know that 8 is the same as 2 cubed. And so this becomes 1 over 2 cubed. And so just notice what's going on here. What does that negative do to this power? Well, it takes the power and reciprocates it. Okay, it takes it from one part of the expression to the other here. So for example, let's say that I am looking at, let's say 3 to the negative 4. Well, one way for me to interpret this is that this is 3 to the negative 4 over 1. And what that negative does here is it causes me to reciprocate that power. And by the way, that would be true if it was in the denominator to start off with. Let's say, for instance, that I'm dealing with 1 over let's say 4 to the negative 3. We'll flip that power there a little bit. What that's going to do is that's going to move this to the other side. I'm going to reciprocate a fraction. So like if you reciprocate, let's say 1/2, the 1 and the 2 flip, and it becomes 2 over 1. I'm going to reciprocate 1 over, okay, 4 to the 3 there. This is going to become 4 to the 3 over 1. Now, this also works. It's a little bit more involved here to do it this way, but it's the same thing. Let's say that I had 3/5 to the negative 2. Now, I could think of this as 1 over 3/5 squared, okay? But without going into a lot of detail about the fractions here, bear in mind that when I'm dividing by this fraction here, the other way of working with that is to multiply by the reciprocal. And so this ends up becoming 5/3 squared. So one of the things I can do here, if you've got a fraction that is the base of the power, that negative can simply be thought of as causing the base of that power to reciprocate. Now, one other thing really quickly here, because this also relates back to some work that we did before. Let's say now that I've got this expression x to the 5th over x to the 7th. This is now going to make this make more sense. When I looked at the quotient of powers earlier, in an earlier video, the power on the exponent, the exponent on the numerator was larger than the exponent on the denominator, so I didn't run into any kind of an issue. Here I will, though, because I know that when I divide powers, I subtract exponents. This is going to be x to the 5 minus 7, but that's going to be x to the negative 2. Well, now I know how to interpret that. That is simply going to be 1 over x to the positive 2. Now, just before I sign off here, you should know that, I mean, these two are equivalent forms of writing it, but there's going to be, you're going to bump into a lot of teachers out there that will consider this to be a simplified form, where you write it, an expression without the negative exponents, okay? Not all teachers feel that way, but you should be aware that some people do, that when they say they want it in simplified form, they do not want negatives in the exponent, they want all the exponents to be positive. Just something to consider.